Hello everyone. Today we are going to look at dimensional analysis and the metric system. So we're going to be taking a look and discussing two different things, but combining them together. So we're going to first look at dimensional analysis as a method of how to approach problems, and then the metric system, what it is, and then how do we use dimensional analysis with it. So, to get started, dimensional analysis is a method for converting, so we're changing units of measurement that shows the equivalence between the measurements. All right, shows the equivalence between the measurements. So what does that mean? So we're converting units, we're changing units of measurement, and as we show the work for this, we're going to show how the units are equivalent to each other, how the measurements are equivalent to each other. So we're actually proving why our answer is true. Okay, so you might have done similar questions to this before in school, and this is something a little more familiar. So we're going to introduce how dimensional analysis is set up with something familiar, and then we'll apply it to the metric system, which might be unfamiliar to some of us. So when we look at a question, there's two things we want to find. We want to find the given, so that's a number with a unit. And then we want to find what our question is asking. All right, and our question is asking for a different unit of measurement. So those are the two key things we want to identify in the question. So how many hours is 643 minutes? So what I like to do is when I find my given, that's my amount with my units, I'm going to go ahead and underline that so I can identify it. And then I always circle what I'm looking for, what my question is asking. This one's asking for hours. Now what we want to consider when we're thinking about this is how are hours and minutes related? Now this is something that we're more familiar with in 1 hour, and we can abbreviate the unit hour to HR. That is equal to 60 minutes. So we know that relationship. So we're going to use that relationship to change minutes into hours. When we set up our dimensional analysis, we're going to show all of these values with their units. So we're going to start with our given value always and write that one down with its unit, its dimension. And then I like to make kind of a little T-chart, and it's just a way of organizing our work. So this is how we set up dimensional analysis. Now what we want to do, the left side is going to be our given. Sometimes a given might have 2 units, like grams per milliliter if it's density. But for now, we're going to ignore this bottom box, okay? And I'm going to cover this up for a second. For this other part, we are going to take these units, this equivalence, and we're going to plug it in like a fraction. Now, we could plug it in 2 ways. I could put 1 hour over 60 minutes, or I can put 60 minutes over 1 hour. I can flip it based on what I need to do. And our units are going to control what we need to do. So what we want to do is always set up the unit we're given. We want to get rid of that. We want it to cancel. So we're going to put it on the bottom. We're going to copy it down to the bottom so that we know where it goes. All right? And then I'm going to put the unit I want, in this case hours, on top. Okay? So the units are showing me where my numbers are going to go, not the other way around. So now I know in 1 hour, there are 60 minutes. I can go ahead and fill in my numbers. So the reason we do this is because when we do our math for these, we are going to multiply the values that are on the top, and we are going to divide by the values on the bottom. Minutes divided by minutes are going to cancel with one another. So we are designing our setup in order for that to cancel and in order for us to be getting the unit we want. So this is part of dimensional analysis. It is setting up the dimensions or the measurements in order for them to cancel out and get the dimensions we want. So mathematically, we have 643 times 1, so that stays the same, divided by 60. So if I go ahead in my calculator, 643 divided by 60, I get 10.71, or yeah, it's 10.71. I could round that to 7 too. And our units for that are hours. All right, so we bring over this unit now that we've found. That's the one that's left. So that's our answer. So in 643 minutes, 10.72 hours have passed. So we can change from one unit to another. Again, using something we're familiar with. So let's try another one, again, with something we're more familiar with. It says, how many inches are 0.82 feet? Now, I don't know that off the top of my head, but I do know that 1 foot is equal to 12 inches. I know that. So I can use that to help me. I'm going to write down my given amount and set up my dimensional analysis, my little table. I also call this the railroad tracks. And we're going to bring down that unit because we want it to cancel, so it always needs to match top and bottom. And then put the unit we want on the top. Now we're going to fill in our numbers. Again, our units control where our numbers go. So I know that 1 foot is 12 inches. So again, we can go ahead and cancel out our feet because we are dividing feet by feet. And we're going to multiply 0.82 times 12. So 0.82 times 12 in my calculator, and I get 9.84. So 9.84. We're dividing by 1 here, but we really don't have to do that in the calculator because it'll give us the same value. And the unit that's left is inches. So 5.82 feet, that's equivalent to 9.84 inches. So these kind of calculations can be helpful in so many ways. I use them in baking if I need to change units from tablespoons to quarter cups or things like that. We can use this method. There's all kinds of ways we can use dimensional analysis. Well, one way we use it in chemistry is with the metric system and doing unit conversions for metric system. Later on in chemistry, we can use it for another unit called stoichiometry, where we do the math of chemical reactions. So dimensional analysis is very foundational to chemistry. So now we're going to explore the metric system. So the metric system uses multiples of 10 and prefixes to represent different sizes of measurements. Oh, I don't know why there's a blank there. We'll leave that out. It's different sizes of measurements. A prefix shows what is being measured, while a base unit, that's a short line there, can be added. Sorry, I mixed this up. I apologize. All right, a base unit shows what is being measured. So things like grams, liters, meters, that's showing us what is being measured. While a prefix can be added to show the size of the measurement. So we can add a prefix like milli, centi, or kilo to indicate the size of the measurement, okay? Now you might be familiar with some of these. So let's just take a look. We'll talk about the base units first. So our base units are grams, liters, meters, joules, moles. We've already talked about how grams measure mass, liters measure volume, meters measure distance, but these other two are newer. Joules measure energy. Okay, so like the energy burned from a fuel, or the energy released when we eat chips. So the calories on your chip bag can be converted into joules of energy. They're the same thing. And then moles are a unit of number of particles. Okay, number of particles. So moles give us help us figure out how many atoms or molecules there are in something. So we'll use that later. Now, I can pair a prefix with any one of these. So I could say milligrams, milliliters, millimeters, millijoules, millimoles, all of those. I can use any prefix with any base unit. That's the nice part about the metric system. We don't have to have a separate name for everything. So these different prefixes have different meanings. So milli is one of our smaller units. So our milli and centi are smaller units. Okay, that means, so for instance, it takes 1,000 milliliters, so I would take my prefix milli and my L for liters, 1,000 milliliters to make 1 liter. So milli is smaller than liter. Milliliter is smaller than a liter. Same thing for milligrams. It would take 1,000 milligrams to make 1 gram, 1,000 millimeters to make 1 meter. Okay, so those are, milli is smaller than the base unit. Similar for centi. Centi means 100, okay? So cent, if you have, like there's 100 cents in a dollar, there's 100 years in a century, so that's where that comes from. So 100 centigrams, so I took that prefix and put it with grams, would equal 1 gram. 100 centimeters would equal 1 meter. 100 centimoles would equal 1 mole. Now I've only listed 3 examples of each, but you could make a whole bunch of, you can make 5 different pairs for each prefix there with these base units. And then over here, kilo is a larger unit. Okay, so if I have 1 kilogram, that's really big. That means that it's 1,000 grams. Okay, if I have 1 kiloliter, I have 1,000 liters. That's like having 500 2-liter bottles, right? It's a lot. All right, if I have 1 kilometer, right, kilometers, that's 1,000 meters. So that is, if I took a meter stick, like we measure in class, the meter stick, 1,000 of them end to end would be a kilometer. Okay, so that's our larger unit for kilo. Now, you might have heard some of these things before, or you might have heard similar ones. If you've ever heard of like our phones, you know, they use gigabytes of data. Well, giga is a prefix and byte is a base unit of data storage. We also store in megabytes and terabytes, right? So that's another one you might be familiar with. There's all kinds of prefixes. There's actually an entire list of them. We don't have to learn them all. These are the 3 we're going to use the most in chemistry. So I'm not going to have you learn the entire metric system just for the 3 that we're going to use all the time. And these are 5 base units, but it's not all the base units possible. There are lots more, but these are ones we're going to see the most in chemistry. Okay, so we're going to focus in and really narrow down to the things we use the most. Now we're going to try some dimensional analysis using the metric system. So what is the mass in milligrams of a 35-gram baby penguin? All right, so there's our given amount, and we're looking for the mass in milligrams. And that's what we're looking for. So just like the others, we're going to write down our given amount first. I'm just going to put G for gram. I'm going to set up my little table, and I'm going to copy that unit to the bottom. And then what I want is going to go on the top. M for milli, G for gram. Now, I'm going to think about what my equivalence is. Now, I do have it written up here for reference. If you needed joules, then you could always have the same relationship there, right? Or millimoles, all of those would be the same relationship. But we can also think about, as we set it up, which one of these is bigger? Well, milli is a small unit, so gram is bigger. So I'm going to put my 1 next to the bigger unit. And then I'm going to think about how many milli are in 1 gram. Well, there's always 1,000 for a milli. So that's another way of thinking through the problem. So again, we're going to multiply and divide. When we divide, our grams are going to cancel. So 35 times 1,000, that's pretty straightforward. We get 35,000. And our units left are milligrams. So a 35-gram baby penguin is the same as a 35,000 milligram baby penguin. All right, let's check the next one. When a gram of carbohydrates is burned in the body, it releases 16,000 joules of energy. How much energy is that in kilojoules? All right, so we're going from joules to kilojoules. Kilo is larger, so we're going from a smaller unit to a larger unit, okay? So we're going to write down our given, J for joules. I'm going to copy my unit to the bottom and write what I want on the top. And again, I'm going to think about which one's bigger. Well, kilo is that larger unit, so I'm going to put my 1 next to the kilo, and then think about, okay, what's my relationship for kilo? Well, 1,000 of my base unit is equal to kilo, right? So here we can divide and cancel those joules. So we've got 16,000 times 1 divided by 1,000. So that gives us 16 kilojoules. Okay. So hopefully this is starting to make sense here. We're just using these similar things, these equivalences, to set up that dimensional analysis. So this last one, a little bit more challenging, but we're going to see the great thing about dimensional analysis with this. A piece of wood measures 157.8 centimeters. What is this length in millimeters? Now let's look. I know like if I did centimeters over here, I know that that's equal to a meter. But I don't know how it's equal to a millimeter. But I do know how a millimeter is equal to a meter. So we have these two pieces of information. They both relate to meters, the base unit. So we can use our base unit here. When we see something, when both measurements have a prefix, we're going to use 2 steps to convert, okay? And we're going to convert to the base unit first. Okay, let's see what that looks like. 157.8 centimeters. Well, let's think about it. I can copy my centimeters to the bottom, and I can go to my base unit. My base unit is just without the prefix, so meters. And I can go ahead and write that relationship down. A meter is bigger, so 1. Centi is 100, so we'll put that there. And now we can cancel those centimeters. It's like they don't even exist anymore. Now, we're going to do this in 2 steps, which means we can add another part, which is why I like to call this the railroad tracks, because you can just add tracks as you need them. Now I have meters, right? I can copy that to the bottom, and then what I want is millimeters, right? And I know the relationship between millimeters and my base unit. Again, my base unit is bigger, so there's my 1. Milli is 1,000, so I fill that in. Okay. So because I know that relationship for each of these, I don't have to also know the relationship between centimeters and millimeters. I don't have to memorize extra things. You really only need to know 3 relationships instead of knowing a whole bunch of other ones. So we're going to multiply all the way across. So 157.8 times 1 times 1,000, and then we're going to divide by 100. So 157.8, I don't have to put the 1, and then we're going to divide by 100. 1,578 is our value. And we're going to put millimeters on there for our units. That's what's left. So if we need to do something that has both measurements have a prefix, that's your hint that you would have to do this, okay? Because if they both have a prefix, we're coming from 2 different columns or 2 different measurements. If we need to do that, we're going to go to our base unit first, what they have in common, and then we'll convert to the one we want. Okay, so you've got that little note here at the bottom to remind you if that happens. So when we start to do our practice, when we do our homework, this is the work we expect to see. This is your dimensional analysis, okay? I don't need to see your long division. You can use a calculator for that. But when we say show your work, we need to see this setup. Every number should have a unit, and you should clearly be able to follow what's going on in your problem. All right? So make sure you're showing your work for your practice, and if you have questions, always ask, all right? Have a great day, guys.